Welcome everyone. Today we are going to discuss about the topic of structural indeterminacy. I am Atrayee Bandyopadhyay, Associate Professor, Civil Department in Health Institute Technology. Let us proceed with our topic. So the list of contents are including the basics, that is equilibrium equations, which is we all know a very important section of basic engineering. And the next is the introduction to structural indeterminacy. That means we will know what is structural indeterminacy and why we are going to learn it. And the next is how many types of indeterminacy there are. That is mainly static and kinematic. Thereafter, the presentation or the lecture includes static indeterminacy, the classification of it, and thereafter the details of the classification, thereafter the kinematic indeterminacy, and the different type of structures, how they are affected, or how the calculation of static and kinematic indeterminacy for different type of structures are done. Thereafter, there are some examples of each type of indeterminacy has been discussed in this topic, and at the last, the comparison of the both has been done, and more. And after that, the importance and application of the same has also been discussed. So let us go through the next topic. The first we will need to learn is equilibrium equation. That is the basic of everything in mechanics. We all know that equilibrium equation is nothing but the three fundamental equations for 2D. That is summation of fx equals to 0, summation of fy equals to 0, and moment equals to 0. That means when a 2D axis is shown, x-axis and y-axis. For here, in 2D, first fundamental equation is fx equals to 0. That means all forces along along the x-axis will be resulting in a 0. Similarly, summation of fy equals to 0. That means all forces along this y-axis will summation will be 0. And last of all is moment equals to 0. Means at a point, moment will be 0. Three equations will be considered as the three fundamental equations in 2D structure for the analysis of structures. Whereas in 3D structure, the equation number comes to 6. That means 3 equations for forces in 3 axes, that is summation of fx equals to 0, summation of fy equals to 0, and summation of fz equals to 0. Thereafter, the moment along the same 3 axes will also be considered as 0. Therefore, the total equations in 3D will be considered as 6. For force there is 3, and for moment there is 3. That means total is 6. Now these type of equation sets are very useful for the analysis of structures. Now for 2D, we came to know there are 3 equilibrium equations, and for 3D there is 6 equilibrium equations. Okay. Now these equations helps us to understand the indeterminacy of structures. Means we all know that how many unknowns can be solved depend upon how many equations are available. Okay. Similarly, here also, if there is 3 equations available there, that means we can solve 3 unknowns using these 3 equations. Whereas if there are more than 3 unknowns, then the problems cannot be solved using these 3 equations, because the number of unknowns are greater than the number of equations available. In that case, the unknowns that are more than the number of equations are unsolvable. That number is called here the static indeterminacy. For 3D structure, available equation 6. For 2D structures, available equation 3. Okay. So let us proceed for the next slide to go through how these equations are used and how these are implemented to calculate the indeterminacy of structures. So first let us study what is structural indeterminacy. Structural analysis actually involves the calculation and determination of the reactions, forces and displacement of a structure. Suppose here is a pin joint at an end. Okay, this is the beam. So we all know that pin joint have reactions, that is vertical reaction and horizontal reaction. As this is a pin joint, therefore here there will be no moment. Means here there will be no moment, only vertical reaction force and horizontal reaction force. Reaction. So degree of freedom is 1 and restraints are 2. Similarly, these type of structures are analyzed considering what type of end supports are there, how many reactions are available. On this condition, the reaction supports are available in the number of calculation of the structural indeterminacy for every type of structures, every type of end condition, the number varies. Okay. Now, the indeterminacy defines the complexity of a structure. Obviously, the number of unknowns there are more, that means the structure is more complex. That means the structure, if the unknowns can be solvable using those equations, then the structure will be easily solvable. But when the unknowns are more, that means the structure will be not be easily solvable simply with using these equations. Therefore, we have to go for higher complicated process to solve the unknowns. That means the higher number of indeterminacy, the more complex the structure is. Okay. Mainly, the indeterminacy has been divided into two types, that is static indeterminacy and kinematic indeterminacy. Okay. So, these two types are, one is static and the second is kinematic. Now, what are these two? We will learn next. Mainly, static indeterminacy is nothing but the number, it is calculated on basis of number of unknown forces. That means how many forces we have unknown that we need to solve. These unknown forces are calculated. Thereafter, the solvable forces are calculated using the unknown equation, forces and the relation of constant equation, equilibrium equation. That means unknown forces and if available equations, equilibrium equations. These two forces and equations result in a number that is solvable or not. If the unknown forces is more than the equilibrium equation, that means there are some forces that will not be available to solve using that equilibrium equation. So that will be its indeterminacy, that is static indeterminacy. So this is calculated based on number of unknown forces, that is including external and internal. And whereas the kinematic indeterminacy is dependent on the displacement, that is the support. If the support is not fixed and support is somehow moving, that is for frames, like for frames. For frames, if there is a force, that means this can sway like this. So for these type of structures also, static indeterminacy is calculated as well as kinematic indeterminacy is also being calculated. Okay. So let us go deeper into the particular static indeterminacy and kinematic indeterminacy. So we can once also see the hierarchical breakdown of the types of indeterminacy and its differences. Like the indeterminacy is nothing but the number of unknowns, including whereas the unknown is force or whereas the unknown is a displacement. Now, what is static? Static indeterminacy is number of unknown forces, whereas the dynamic indeterminacy is number of unknown displacements. Now, static indeterminacy is also can be calculated in two parts, that is the internal static indeterminacy and the external static indeterminacy. The internal static indeterminacy, the name itself refers that it is nothing but the internal unknown forces, whereas the external static indeterminacy is number of external unknown forces. That is whether the forces are internally available or externally generated. Okay. So indeterminacy and its classification has been shown in this hierarchical breakdown clearly. Now, in the next slide, what is static indeterminacy? Static indeterminacy is nothing but what we have discussed in the last slide also, is the degree to which equilibrium equations are insufficient to determine the unknowns. That means static indeterminacy is nothing but the number of unknown reactions and how much it is greater than the equilibrium equation. That means if the unknown reactions are, let us assume 4 and the equilibrium equations are for 2D it is 3. That means this is obviously greater than this. That means here degree of static indeterminacy is 1. That is 4 minus 3 equals to 1. Okay. Similarly, that means one number of unknown is not solvable because 3 equilibrium equation is used to solve 3 unknowns, but here the unknown is 4. So there is one more unknown which cannot be solved using the equilibrium equation. That is the degree of static indeterminacy here is 1. Okay, the formula is nothing but reactions plus internal forces minus equilibrium equation. Okay. Next, how many divisions are there for static indeterminacy? Static indeterminacy includes internal static indeterminacy and external static indeterminacy. Now, what is static indeterminacy? It is nothing but the summation of these two: static indeterminacy for internal and for external. Okay. Next is external static indeterminacy. Now, the excess number of support reactions over the equilibrium equation. That means, similarly, what we just discussed, if there is a pin joint, then here reaction will be RB, RH. So, here there will be two reaction forces unknowns. Similarly, if a total structure, there will be number of unknown forces as reactions. That number of support reactions as unknown forces minus the total number of equilibrium equations, static equilibrium equation available, will determine the degree of static indeterminacy. Okay. Now, the kinematic indeterminacy. Sorry, internal static indeterminacy. The internal static indeterminacy is nothing but the deduction of external static indeterminacy from total static indeterminacy. Okay. The excess number of internal member forces or internal constant beyond what equilibrium can be solved. That is, it arises when there are redundant members or closed loops in a truss frame. Okay, that means if there is a truss frame with closed loops, here it is a closed loop. So for here there will be values. Now let us go to kinematic indeterminacy. Okay, so till now we have learned what is static indeterminacy. For kinematic indeterminacy, we will go on our next lecture. Okay, see you on our next lecture for the continuation of this topic.